Alright everybody, today's video, rational functions, vertical and horizontal asymptotes. So the way I decided to do this is not by, at least at first, showing you any of the math, but by just showing you what the graph is going to look like for this kind of function. Alright, so I'm not going to worry about the definition of a rational function or all the math between what a vertical asymptote is or what a horizontal asymptote is. I'll just show you what it's going to look like, okay? So when we graph this kind of function, a rational function, it's going to look something like this, all right? And so there's a few features of this that I want to jump out at you. In red here, this is what I'll say is a vertical asymptote, okay? And this horizontal red line here is a horizontal asymptote. And you notice, like in pencil, I've drawn a sample graph there. And as you go up or down, the graph gets closer to the vertical asymptote. And as you go to the right or to the left, it gets closer to the horizontal asymptote. Now, there's more to it than that, and that's a real simple way of saying it. But that will do the trick for us, okay? That'll work for now. All right, so if I knew, like say I had to sketch one of these graphs, I had to figure out what it looked like, then I could plot a few points, I could know where these asymptotes are, and then if I know that as I go to the right, or as I go up or down, or left, it's gotta get closer to these lines, then that sort of makes the picture complete itself from there, okay? All right, so that's the simple story. I mean, it could make it way more complicated than that, but that's a pretty simple way of saying it, I think, okay? Now, I want to learn to do this, I want to understand these things through drawing some of these graphs from scratch, okay? I know you could get a graphing calculator to do it. I mean, that's no mystery to me. I think anybody can get a graphing calculator to draw it, but I think you'll understand what you're dealing with the best if you can do this all by yourself. All right, and that's what I'd like you to learn to do. So let's look at, I got 3 examples lined up for us. And here we're looking at the first one, okay? So for this particular function, that would be a rational function, I want to find the vertical asymptote, the horizontal asymptote, the x-intercept, that's wherever it hits or crosses the x-axis, the y-intercept, wherever it hits or crosses the y-axis. And then just to fill in any gaps, I'll make a table with some extra points. All right? Okay, so let's do each of these things. So I'll try to do my work over here. So 1, the vertical asymptotes, which I'll abbreviate VA for that. That would be found wherever the denominator equals 0 and the numerator does not. So here, that's just going to amount to where does x plus 3 equal 0. Whatever the answer to that is, that's where the vertical asymptote is going to be. All right? Okay, so well, that's a pretty easy equation to solve. We just subtract 3 from both sides, and we get x is equal to -3, okay? So what's that? That's going to be a vertical line that goes right through -3 on the x-axis. The vertical asymptote is not a number. It's a line. It's a vertical line, okay? All right, so the vertical asymptote is, I mean, at least for this problem, as easy as doing that. What about the horizontal asymptote? Well, here we have to look at this thing in a little more detail. If the highest power of the x on the bottom is bigger than whatever it is on the top, then the x-axis is the horizontal asymptote. That's what we have here. What's the biggest power of the x down there? It's a 1. And what's the biggest power of the x up there? Well, there isn't an x, so I guess it would be 0. All right, so it's larger down there than it is up there. So that just makes the x-axis okay, is the horizontal asymptote. What's the x-axis? Can I say the x-axis like this? The vertical asymptote was x equals -3. The x-axis is a horizontal line, y equals 0. The horizontal line that goes through 0 on the y-axis is the x-axis. All right, so that's how we do the horizontal, in this case at least. So the x-intercept, that would be wherever it touches the x-axis, okay? So well, let's think of it this way. Here's how we can always find an x-intercept. What's true of every point on the y-axis? What's true of every point on the x-axis? Sorry. Every point on the x-axis has a y-coordinate of 0. Okay? That's true of every point on the x-axis. You don't go up or down to get to the x-axis. So if I put y is equal to 0 and solve it, then I'll find the point where it hits the x-axis. Okay? So I'll put y to be 0. That would amount to this number over here being 0. I'll get 0 is equal to 1 over x plus 3. I'll solve this. I'll multiply both sides by x plus 3. And I'll get like so. But then that says that 0 is equal to 1. And that's a false statement. Obviously, 0 is not equal to 1. And if you're trying to solve a problem and you reduce it to a false statement, say the x just drops out of it, disappears somehow, then that means there's no solution. So that means there isn't an x-intercept. Okay? So we'll say no x-intercept. This graph does not happen to hit the x-axis at all. It never touches it, never crosses it. So that's something that we can keep in mind when we draw it. So 3, done. 4, y-intercepts. Well, you can just sort of reverse your thinking for the x-intercept. So the y-intercept, that would be on the y-axis. What's true of every point on the y-axis? X is 0. So if we put 0 in for x, we'll find where it hits the y-axis. Okay, so I'll take this equation, y equals 1 over x plus 3. I'll put 0 in for x, and I'll get 1/3 for y. So the y-intercept is this point, 0 for x, 1/3 for y. Okay, so that's how we do most of it. That's 4 out of 5 parts, all right? But what about making a table? Like, let me show you what I have so far. Okay, so let's say ultimately my goal is to draw the graph, all right? So I'm going to pretend like I have a graph paper right here. Here's what I know so far. I have this vertical line at x equals -3. And the graph sort of forms itself to that. Okay, so I'll put that right here. So the vertical asymptote is not part of the graph. It's just this feature we use to draw the graph. But there it is. A vertical line through -3 on the x-axis. What else do we know? Though the x-axis is the horizontal asymptote. Okay, so I'm going to try to, best I can, I want it to show up here. So I'm going to just draw it kind of right above the x-axis so you can see it. Alright, so see that red line right there? That's the x-axis. That is the horizontal asymptote. Okay. Alright, so the graph kind of like somehow like goes up closer to that line, and as you go to the right, you're closer to this line. As you go to the left, you're closer to that line, and so on. Now, alright, the only thing we need to do from now is get some more points, right? I know the graph kind of forms itself around these lines. It's like that first one I showed you, right? I said this is basically what they're going to look like. Then I'll make a table real quick, okay? So the graph is made from points anyway. That's all it is a bunch of points. What's a point? A point is just numbers that work in that equation. All right. So here's my table. I'll plug in an x. I'll plug it in y is 1 over x plus 3. Okay. All right. So here's the points, that I think would kind of fill things in. Let's do like some over here, like -5 and -4, like out there. Let's do some on this side too. So like -2, -1 maybe, and then maybe 1 over here too, 1. All right. So that should do it. I think that'll be enough points to fill in the shape for us. So we'll just have to do the math at this point. So say I plug in -5 there. -5 plus 3 is -2, so I'll get -1/2. Okay. Say I put -4 in. -4 plus 3 is -1. 1 over -1 is -1 to get that point. Say I put -2 in. -2 plus 3 is 1. 1 over 1 is 1. All right. Say I put -1 in. I'll get 1/2. And if I put 1 for x, I'll get 1/4. All right. And if you want decimals, like if that would be easier for you to graph, this is -0.5, positive 0.5, this is 0.25, whatever, just however you want to look at those numbers doesn't really matter. Okay. All right. So let's see. I will now plot the points. Now I get left 5 down 1/2. Okay. So that would be about right there. If that's -1, I mean that's roughly 1/2. And then left 4 down 1. So that's going to be right there. Okay, so all right, remember it's as I go down, I've got to get closer to this line. As I go to the left, I have to get closer to this. So I think I've got it. This part over here looks like that. Okay. All right, what about the rest of these points? -2 and 1, so that's going to be left 2, up 1. -1 and 1/2, left 1, up 1/2. And then 1 and 1/4. So right 1 up 1/4. Where's a 4th? That's like, 0. This is 1. A 4th is like 0.25. I'll have to put that pretty close to the x-axis. Are there any other points? Let's see. There's no x-intercept. It never hits the x-axis. But it hits the y-axis at 0 and 1/3. So 1/3 is a little bit higher than this point, a little bit lower than that one. So something like that. Okay, now remember, as we go up, it's got to get closer to this line. If we go to the right, it's got to get closer to that one. So I think I've got it. I think it's going to go like this. On that side, go like this over here. As we go to the right, it gets closer to the horizontal asymptote, never touches it, just gets closer and closer to it. That's how I've drawn it, just kind of closing in on the x-axis. And as I go up, it gets closer to the vertical. Okay, so I tried to draw it where it's just kind of closing in. What if you had any doubt about that? You plot more points, all right? If you plot more points, you're going to get one here, you're going to get one there. The more points you have, the more this picture is going to come into focus. So that table, how many points do you need for it? Well, it's however many points you want to be able to see it, okay? All right, so there's my first example. Let's look at another one. Okay, so same thing with this. Let's say I'll do the same series of questions. In order to graph it, I'll find the vertical, horizontal asymptotes, x and y intercepts, and make a table to fill in the gaps from there. Okay, so let's do this first. What is the vertical asymptote? So what do we say was the technique for finding that? It's whenever the bottom is 0 and the top is not. So in a case like this, that's just going to mean, what's it take for x squared minus 4 to be 0? Okay. So I guess to solve this, there's different ways you could do it. I guess factoring is a way most people are probably familiar with. Like I can take that, I can factor it this way, And if either of these factors is 0, I have an answer. So -2 makes that one 0, so that's one of our solutions. And 2 makes this one 0, so that's the other. Alright, so there they are. Imagine these vertical lines that go through -2 and 2 on the x-axis. Those are the vertical asymptotes. Alright, so 2. What are the horizontal asymptotes? HA, abbreviation. Well, okay, so on the last problem I said, well, if the highest power on the x on the bottom is larger than the highest power on the x up there, then the x-axis is the horizontal asymptote. What's another way of saying the x-axis? The equation y is equal to 0. The horizontal line that goes through 0 on the y-axis. Okay, so the x-axis is the horizontal asymptote. What was the third thing that we did? X-intercept. What's that amount to? What's being on the x-axis mean? It means y is equal to 0. So we take our function, our equation, put 0 for y, and we try to solve it. And what I would do is multiply both sides by x squared minus 4. Here's what I'll get. But what does that look like? What's 0 times x squared minus 4? Oh, that's 0. What do we get? Where'd the x go? The x disappeared out of it. Is 0 equal to 2? No, that's not true. That's definitely false. And so we said if you're trying to solve a problem, trying to solve an equation, the variable you're trying to solve for drops out and it's false, that means there's no solution. So there's no x-intercept. This graph, when we draw it, never hits the x-axis, never crosses the x-axis. Okay? And 4, what was that? That was the y-intercept. Okay? What's it mean to be on the y-axis? What's true of every point on the y-axis? The x-coordinate is 0. I promise you, for every point on the y-axis, x is 0. So we put 0 in for x. We'll find that point on the y-axis. That's the y-intercept. So I take my equation that you see up there, and if I put 0 for x, I get that. And this turns out to be 2 over -4. Okay? But that is a negative number. A positive number divided by negative is negative, so I'm going to say negative. 2 over 4, though, is 1/2. Okay? So where does it hit the y-axis? At the point 0 for x, -1/2 for y. Let me box that just so it stands out. All right? Okay. So I think I have what I need there. Okay? Let me. So I'm gonna draw the graph at this point. All right. So put it over here. Here's what I know so far. Okay. Let's draw. I don't have actual graph paper with me, so I'm gonna do something like that. So here's what I got. I know that the vertical asymptotes are these lines through -2 and 2 on the x-axis. So that would be like this. Okay. And like this. Okay. Well, here's the line x is equal to 2, and the line x is equal to -2. All right. And the horizontal asymptote is the x-axis. Okay. Which I hope I can draw bold enough that it stands out and that you can see it. Okay. So there's the x-axis, and kind of faintly there, with my red pen, I drew the horizontal asymptote. Okay, the x-axis is the horizontal asymptote. Okay, and do I have anything else? Well, I know it never hits the x-axis, never touches the x-axis, never crosses it, but it hits the y-axis at 0 and 1/2. Okay. All right, so I'll include that point when I put my other points down. Where am I going to get more points to figure out exactly how to fill this in? I'll make a table. Okay? A table is a bunch of points, and points are what the graph is made of. All right, there's my table. I'll choose some x's to fill in all the gaps. I'll plug in to y is equal to 2 over x squared minus 4, and I'll get some points. So how about some out here? Okay, let's do -4, -3. Okay, I need some in here. So let's do -1 and +1. And then I need some out there. How about 3 and 4? Now, who knows, if I need more points, if this is not enough to fill it in for me, then I can always choose more points. Okay. All right, so what's -4 going to give me? 2 over 4 squared, so that 2 over 12. That's going to be 1 over 6. Okay. If you'd rather have a decimal, that's a pretty small number, 0.16 roughly. All right. What if I put 3 in? 2 over, so 2/5. Okay. 2/5. That's equal to 0.4 if you want a decimal. That would help you graph it. What do I get for -1? Okay, so -2/3. That's equal to about 0.67 or so. For 1, I'll also get -2/3. That's also about -0.67. Sorry, -0.67. For 3 and 4, I'll get 2/5 again. 0.4 and 1 over 6, which is about 0.16. Okay, so there's the fractions or the decimals, however you want to look at it, right? Just get the points on there in the right spots, okay? So left 4 and then up 0.1, that's going to be like not very much. So left 4, that point's really close to the x-axis. And then left 3 up 0.4. That's going to be, let's see, left 3, that's a little higher up, so about like that. But what has to happen? As I go up, I have to get closer to this line. As I go to the left, I have to get closer to that one. So I think these 2 points tell me the story. And it goes something like that. All right. So what about in here? Left 1 down 0.6. 0.6 is about there. And right 1 also down 0.6, so about right there. Anything else in here? Oh, the y-intercept hits the y-axis at -1/2, so that's right about there. Okay, if I go down, I have to get closer to this line. And this one, you see those 3 points? That's what they're suggesting. The rest of it's probably like this. Okay. And now on the other side, okay. I have left 3 up 0.4, about right there. You know, that's 1. And right 4 up 0.16. It's really close to the x-axis. Right 3 up 0.4, right 4 up. Okay, so I get points like that. And as I go up, I got to get closer to this line. Let's go to the right, got to get closer to that one. So let's see where those points are. Probably does like so. I'd be comfortable with this conclusion, right? There it is. Got all the features I want. It's got my points, the vertical asymptote, the horizontal. As I go up, it gets closer to the horizontals. If I go down, it gets closer to the horizontals. If I go to the right, if I go up or down, it gets closer to the verticals. As I go right or left, it gets closer to the horizontals. That's what it's supposed to do. And then the points fill in the picture from there. All right, so let's look at one more. This last example, I think we'll see everything we need to see. Okay? All right. So same series of questions. First, what's the vertical? So that's going to amount to whenever this bottom part is 0. Okay? What's it take for x minus 1 to be 0? If I add 1 to each side, I would get 1. So see this, imagine a vertical line that goes through 1 on the x-axis. That's the vertical asymptote. So 2, a horizontal. All right. What's different about this one compared to the last one is the highest power of the x on the bottom is the same as the highest power of the x on the top. They're both 1. You know, if they're equal to each other, then the horizontal asymptote is the coefficient of the x up there, which is 2, divided by the coefficient of the x down here. What do I mean by coefficient? The number multiplying the x. 2 times x. 2 is the coefficient. Down here it would be 1 times x. 1 is the coefficient. So the horizontal asymptote is a horizontal line. It's not a number. It's a horizontal line that goes through 2 on the y-axis. Okay? So if the powers of the x's are equal, top and bottom, we'll just get that number, get that line by taking this coefficient, divide by that one. All right, 2 over 1 is 2. That's the horizontal asymptote. So let's look at 3, the x-intercept. Here we've done this 3 times by now. What does it mean to be on the x-axis? Well, y has to be 0 on the x-axis. Okay, let's put 0 for y. See? 0 equals 2x plus 5 over x minus 1. Multiply both sides by x minus 1. 0 times x minus 1 equals 2x plus 5. All right, where do we go from there? Well, what's 0 times x minus 1? What's 0 times anything? 0. So then we get like so. Solving that, subtracting 5 from both sides, and then dividing by 2, we'll get x is equal to negative 5 over 2. Hits the x-axis at negative 5 over 2. All right? Okay. What's that? That's negative 2.5. That's where it hits the x-axis. All right, so we've got our x-intercept right there. So what was the next thing? The y-intercept. What's it mean to be on the y-axis? It means x is 0. Okay. So, well, okay, so we put 0 for x. What are we going to get? Y equals 2 times 0 plus 5 over 0 minus 1 is negative 5. It hits the y-axis at negative 5. All right, so we've got quite a bit right there. Let's put this on our picture and then fill in the gaps with some more points, all right, just like the others. So here's what I'll put what I have so far. Okay, let's see. So here I'm making some makeshift graph paper. So I know the vertical asymptote goes through 1 on the x-axis. Okay. So like so. There's the VA, x equals 1. The horizontal asymptote, horizontal line that goes through 2 on the y-axis. Well, let's see. 1, 2, okay. So right here. There we go. So there's y is equal to 2, horizontal asymptote. What else do I got? It hits the x-axis at negative 2.5. So let's see. If I go over 1, 2.5, that point right there, and it hits the y-axis at negative 5. Okay, so let's see. 1, 2, 3, 4, 5. Okay, so right here. So I got my x and y intercept. I would imagine it sort of goes like this, right? Because as you go to the left, it has to get closer to the horizontal asymptote. As you go down, it's got to get closer to the vertical. But maybe we'll do a few more points. All right? And over there, what happens? Well, I don't have any points over there. All I got so far is the x and the y intercept. So let's make a table, get a few more points. And graph as many points as we think we need to be sure that we're seeing the picture the right way. Okay, so let's choose like -3 and I don't know, how about -1? Okay, all right, if I put -3 in, let's see, I'll get 1, so it's -6, so that's -1 over -4. So I'll get 1 over 4, which is 0.25. If I put -1 in, I'll get -3 over 2, which is -1.5. All right? Okay, so that would give me a few more points out here. So let's do on the other side. Let's do 2 right here, like this one, and let's do 3. And that's probably enough. So if I put 2 in, I'll get 9. Okay? And if I put 3 in, I'll get 11 over 2. Okay? 11 over 2 is 5.5. All right. So that will probably be enough. But if I'm putting the points on there and it looks too random, I might get a few more. Okay? So let's see. Left 3, up 0.25. That might be like right here, just a little bit above the x-axis. Left 1, down 1.5. That's going to be, so 1.5, about right there. Okay. Right 2, up 9. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So way up there. Right 2, up 9. There's my point. And then right 3, up 5.5. So that's going to be about right here. Okay. Now, with these points being where they are, what else has to happen? As we go to the left, we get closer to the horizontal. If we go to the right, closer to the horizontal. Down or up, closer to the vertical. So it looks like it'd have to go, if it has those points on it, down kind of like this. Okay. All right. Right? And then with these points on it, getting closer to the vertical and closer to the horizontal, going through those points. Something like that. Alright, maybe I'm trying to be too much of a perfectionist drawing it, but there it is. That does everything it's supposed to do, right? It's got the points on it, it forms to the vertical, it forms to the horizontal. And it looks like that very first picture that I showed you, I said they're going to look something like this, alright? Well, once you have all those details together, you can fill in the rest of it with your imagination, and that's what this picture is.